morning all. Now let us discuss about the DT based signals and systems, design thinking based signals and systems. What is meant by signal? A function of one or more independent variable which contains some information is called as a signal. It is of different types such as continuous time signal and discrete time signal. We will discuss elaborate.
We are going to discuss about DT-based signal. Design thinking is a human-centered approach to innovation that involves understanding the user needs and creating innovative solutions to prototype and test. Empathize start with a discussion on where students have encountered signals in their everyday life. Define explain importance of understanding signals and systems in various engineering fields. Ideate introduce basic concepts through interactive and relatable examples. Prototype use simple hands-on activities such as recording and analyzing their voice signals.
Now the noise reduction using signals and systems. In this empathy part, understand the challenges faced by the users by recording the audio in a noisy environment. Formulate the problems by increasing the signal clarity and avoid the noise from the environment. For this, we are giving the ideas like Brainstorm solutions like auto error, advanced error correction codes, adaptive filters, and novel modulation techniques. And we are designing this prototype and testing by the users by recording audio in a noisy environment, and it automatically separates the noise and clear signal.
I'm going to talk about enhancing real-time signal processing in medical devices. First, empathize. Engaging with medical professionals and patients to understand the critical requirements. Define. Formulate the problems for accuracy and reliability in medical devices. Ideate. Brainstorm solutions for efficient filtering algorithms. Prototype. Creating hardware and software prototypes. And for testing, validate the prototypes to ensure the performance and safety standards.
I'm going to talk about signals. Signals, a function of one or more independent variables which contain some information, is known as signal. And in signal, it is classified into electrical signal and non-electrical signals. Non-electrical signals mean sound signal and pressure signals are known as non-electrical signals. TV signals and radio signals are known as electrical signals. Excitation signals, which are applied at the system's input, and the response signals are produced at the output. Signal is classified into two types: continuous type signal and discrete type signal. Continuous type signal is defined as for every instant of time, it produces continuous time and continuous in amplitude. It is known as continuous type signal. In discrete type signal, a signal that is defined for discrete instance of time is known as discrete type signal. It produces continuous amplitude and discrete in time.
It is of another types of periodic and aperiodic signal, even and odd signal, energy and power signal, deterministic and random signal. See, periodic signal means a signal is said to be periodic if it repeats at regular intervals. If do not repeats at regular intervals, is called as aperiodic signal. See, even and odd signal is also known as symmetric and anti-symmetric signal. See, even signal means if the inversion of time axis does not change the amplitude. That is nothing but cos of minus theta is equal to cos theta. For anti-symmetric signal, a signal is said to be an anti-symmetric if the inversion of time axis also inverts the amplitude of the signal. That is sine of minus theta is equal to minus sine theta. Next we can going to say about the energy and power signal. Energy signal is if the finite energy is finite and non-zero, total energy is finite and non-zero, and power signal is total power is finite and non-zero. Condition for power is 0 less than power signal less than infinite. Deterministic and random signal, a signal which can be completely represented by any mathematical equation is called as deterministic signal. Example, sine wave, cosine wave, etc. Random signal means which cannot be represented by any mathematical equation is called as random signal. Example, noise signal.
Standard signals. The standard signals can be represented in two types, both in continuous time signal and discrete time signal. For continuous time signal, the variable of time is in continuous, and for discrete time signal, the variable of time is in discrete. The types of standard signals are unit step signal, unit ramp signal, unit impulse signal, exponential signal, and sinusoidal signal. For unit step signal, it can be represented in both graphical and mathematical representation. Let's talk about the mathematical representation for continuous time signal. U of t is equal to 1 for t greater than or equal to 0, and u of t equal to 0 for t less than 0. For discrete time, u of n equal to 1 for n greater than or equal to 0 and u of n equal to 0 for n less than 0. And for unit impulse signal, the continuous time signal is del of t equal to 1 for t equal to 0 and del of t equal to 0 for t is not equal to 0. And for discrete time, del of n equal to 1 for n is equal to 0 and del of n is equal to 0 for n is not equal to 0. The unit ramp signal can be represented in both types, continuous time and discrete time. And for continuous time, r of t equal to t for t greater than or equal to 0 and r of t equal to 0 for t less than 0. And for discrete time, r of n is equal to n for n greater than or equal to n and r of n equal to 0 for n less than 0.
Now let us discuss about the exponential signal and sinusoidal signal. See, exponential signal is defined as that is nothing but x of t is equal to a into e power at. E defines your exponential signal. It is of DC signal, exponentially rising signal and decaying signal. A is equal to 0, that is nothing but a DC signal. A greater than 0, exponentially increasing signal. Less than 0 means exponentially decreasing signal. And we can going to see about the sinusoidal signal. Sinusoidal signal is defined as x of n is equal to sine of omega naught n. Now let us see the systems.
Following the system. System is a set of elements or functional blocks which are connected together to produce an output with a response of input. A system takes an input response to produce an output response. It has two types of systems: continuous time system and discrete time system. In continuous time system, it operates the continuous time signal to produce another continuous time signal. It is denoted by t. In discrete time signal, it operates discrete time signal to produce another discrete time signal, and it is denoted by n.
Application areas are communications, audio and speech processing, image and video processing, circuit design, biomedical engineering and electrical applications. Its applications are communication system, applying design thinking to improve modulation scheme, error corrections algorithm and overall system robustness to enhance user experience in telecommunication. Medical devices, designing advanced signal processing techniques for medical devices like ECG machines, MRI, scanner and to improve accuracy and reliability. Consumer electronics, enhancing audio and video processing algorithm in consumer electronics to deliver superior quality. Autonomous system, developing robust signals processing algorithm for autonomous system, for example self-driving cars.
Thank you.